All right, example 6, divide 6.039 by 0.03. All right, and again, division order matters. With division problem, this is 6.039 divided by 0.03. That's what it looks like written in a division symbolism. When you're writing division symbolism, the first number that comes up in a division problem is the dividend, and the second number is the divisor. When you're writing out your long division with the nice little quotient bar like so, the divisor goes on the outside and the dividend goes on the inside. And go ahead and put the decimals where they belong in the numbers, so the numbers that you see are the numbers you write into the division problem like so. We don't want the divisor to be a decimal number, Amber.
What?
What do you need?
Nothing.
Oh, you're just stretching?
Yeah.
Okay. All right. Sorry, I thought you were raising your hand. All right, so we don't want the divisor to be decimal. I don't care if the dividend is decimal, but I want the divisor to be decimal. So what I have to do is I have to slide this over as far as it needs to go to make it into a whole number. So I'm going to make this into 3, which is 2 spaces that I moved it, so I got to move this 2 spaces to account for it. All right? Let me show you why that happens and why you can do that. Because some people just do things blindly and don't know why anything happens. Let me show you why. We all know about fractions, right? Division's like a fraction. The first number is like the top of the fraction. The second number is like the bottom of a fraction. Suppose I had the fraction 1/2. If I multiply this times 5 and that times 5, I get 5/10, right? And those are equal to each other, right? Equivalent fractions?
Mm-hmm.
Okay. Moving the decimal point 2 spaces to the right is multiplication by 100. If I multiply this times 100 to make the bottom equal to 3, and multiply the top by 100 to make the top equal to 603.9, this fraction equals that fraction. That's all we're doing is we're multiplying by a power of 10 to move those decimals. Both decimals have to move the same amount. That's why it works. And again, we want this number to be a whole number because it's easier to divide whole numbers than it is to divide decimals. So that's why we want to do it. This is why it works. And then it's just a matter of division. I personally strike out those extra numbers in front because I don't like to look at them. And it's just a matter of dividing 3 in each number. Notice 6, 0, 3, and 9 all divide evenly by 3. You don't have to do all the stuff underneath. It just divides all evenly.
Is it 2?
What?
Yeah, 2.
Oh, dang it. I'm trying to save time and I end up wasting time. Sorry about that. 2. All right. 6 divided by 3 is 2. 0 divided by 3 is 0. 3 divided by 3 is 1. Decimal point goes up on the quotient bar right where it belongs from that. And then 9 divided by 3 is 3. All right. If you get a situation like that, fine. If it was, let's say this was a 7. Now I'm going to do 60 divided by 7 is 8. And then 56, subtract, you get 4, 43, and so on like that. So like 2 times 3 is 6, subtract, you get 0. Bring the 0 down. 0, bring the 3 down. 3 divided by 3 is 1, times 3, subtract, you get 0. Bring the 9 down. 3 into 9 goes 3 times, subtract, you get a remainder of 0. Okay. If you can do this, just straightforward like that, then don't worry about all this. But again, if it was more complicated, then go ahead and go through the whole long division process. This year in this class, we're going to be dividing polynomials. Like that. And the process to do that is equal to this process here. We're going to use this process to do that problem. We're just going to throw in some rules of algebra to be able to do that problem. So practicing the long division process is important so that when we get to the algebra part of it, we can handle that and make sense of it. So keep that in mind, that there is a purpose for doing this in this class rather than just reviewing stuff. But just kind of going through and still having the mechanics of division is important.